All right, we are going to wrap things up this semester with complex numbers. We have worked with I a little bit in the past when we were talking about imaginary solutions, and today we're going to be expanding on that. So if you will recall, I is equal to the square root of -1, and we use I when we're representing imaginary numbers, imaginary solutions. Now, because I is the square root of -1, if I square both of these, I get that I squared is -1. This is going to be important when we're doing operations with our imaginary numbers. Now, what is a complex number? A complex number is a number that has a real and imaginary component. So remember, with our imaginary numbers, if I have the square root of a negative number, I rewrite it in terms of I by bringing out the negative outside of my radical and replacing it with I. So the square root of your number, I, is how you rewrite it as an imaginary number. And if I am adding or subtracting a real number on that imaginary number, that is called a complex number. Now, one thing that is important is when we're writing complex numbers, the real portion always comes in front. So a plus or minus something with I. Okay, so we have a real part and an imaginary part. And I, just like any other thing that has a common term, whether it's X, Y, Z, A, B, if those terms are like terms, you can combine them. So we're going to do some practice with operations in our complex numbers. So we're going to start with some imaginary stuff first. So on example 1, we're going to first rewrite this in terms of I and then simplify. So on A, I have the square root of -4. So to write that in terms of I, that's going to be the square root of 4I. I'm bringing out the negative by replacing it with I. Now 4 is a perfect square, so this simplifies into 2I. B, similarly, I've got the square root of -4/25, so I'm going to rewrite that in terms of I. That would be the square root of 4/25I. And 4/25 is also a perfect square. That is 2/5 I. Okay, on C, I've got 3 different ones. Let's rewrite each of these in terms of I. Square root of -49, that's going to be the square root of 49I, minus the square root of -9, that'll be the square root of 9I, and then plus the square root of -36, that will be the square root of 36I. And each of those is a perfect square. So I'm going to have 7I minus 3I plus 6I. And these are like terms, so I can add and subtract their coefficients. 7 minus 3 plus 6 gives me 10I, just like if I had 7x minus 3x plus 6x. So that's why rewriting it in terms of I is important, because then we can simplify. Now, we can also do other operations with our imaginary and complex numbers, such as adding, multiplying, subtracting, dividing, etc. But remember, you can only add and combine the like terms. So on example D, let's start here. I am adding these 2 expressions. So I'm going to go through and I see this radical is not written in terms of I. So we're going to take care of that first. My first parentheses is not going to change. That 2 is not going to change, but I want to rewrite this as the square root of 8I. Now, the square root of 8 itself is not a perfect square, but I can simplify it. 8 has a factor that's a perfect square, which is 4. So this can be rewritten as 2 square root of 2I. Now I can combine my like terms. I have 2 constants, 6 and 2. Those add to 8. And remember, the real number always goes in the front for complex. And then I've got 3I and -2 square root of 2I. I can't combine the 3 and -2 square root of 2, so what I'm going to do is leave it as 3 minus 2 square root of 2I. So I can't combine those because this one's not a radical, but I can leave it like this with I on the outside. Okay, on E, I am squaring a binomial, which means I am really foiling, and I've got an I in there. So 3 times 3 is going to give me 9. 3 times 2I is going to give me 6I. 2I times 3 is going to give me another 6I. And then 2I times 2I is going to give me 4I squared. So that 9, I don't have anything I can combine it with just yet, but 6I plus 6I combines to 12I. And then remember something we talked about up at the very top is that I squared is equal to -1. That's where this is going to become important now because I have 4i squared, which is 4 times -1. 4 times -1 is -4, which I can combine with that 9 in front. So this is 5 plus 12i. Now remember, the real number always comes in front. Okay, on F, I'm foiling again. 8 times 2 is going to give me 16. 8 times -5i is going to give me -40i. 3i times 2 is going to give me 6i. And 3i times -5i is going to give me -15i squared. So again, I can combine my middle I terms. That's going to give me 16 minus 34i. And then I have -15 times I squared, which is -1. -15 times -1 is positive 15. So I can add 15 to this 16, and my final answer is 31 minus 34i. So just like every other operation we have been doing with regular numbers, we can also do those with I, including raising them to exponents. So let's look at what patterns we might see when we're raising it to different exponents. I to the first power, that's just itself, right? That's just going to be I. And then I squared, we've already established, is -1. Well, now if I go to a higher exponent like 3, let's think about how we can determine what that is. Think about your product rules. Remember, when you're multiplying like terms, such as x squared times x to the first, you add your exponents and that gives you x to the third. Well, the same thing can be said about i's. So I to the third would be equivalent to taking I squared times I to the first. Well, I know I squared is -1, and I to the first is just I. Well, -1 times I is -I. Okay, let's continue going and see if we see a pattern. I to the fourth, again, using my exponent rules, that would be like I to the third times I to the first. Well, we just solved that I to the third is -I times I to the first is just I. This gives me -I squared, and we know I squared is -1. The negative of -1 is +1. So far we've gone I, -1, -I, +1. Let's keep going and see what happens next. For I to the fifth, that would be I to the fourth times I to the first. And we know I to the fourth is +1. I to the first is just I, so this gives me I again. I to the sixth, that would be I to the fifth times I to the first. We know I to the fifth is I, and I to the 1 is I. So this gives me I squared, which I know to be -1. I to the seventh, that's going to be I to the sixth times I to the first. So -1 times I, that's -I. And then I to the eighth, that would be I to the seventh times I to the first. So -I times I, again, that's -I squared. I know I squared is -1. The negative of -1 is +1. So what we have seen, just to recap at this point, is I, -1, -I, +1. I, -1, -I, +1. So this pattern is repeating every 4. So every fourth multiple of my exponent, it is repeating, right? 1, 2, 3, 4. 1, 2, 3, 4, the pattern repeats again. So you can find I to any power by dividing your exponent by 4 and using your remainder to solve. So let's do that here. On I to the 20th, if I divide 20 by 4, I get 5 remainder 0. Because my remainder is 0, that means I have gone all the way through the cycle to the very end. So I to the 20th would be +1. On B, my exponent is 27. If I divide that by 4, I get 6 remainder 3. So I'm going to be at the third station, 1, 2, 3, in my pattern. So I to the 27th is -I. I to the 33rd, if I divide 33 by 4, I get 8 remainder 1. So it's going to loop back to the first step in my rotation. So I to the 33rd is I. And then lastly, if I have 97 divided by 4, that's going to give me 24 remainder 1. And again, I'm going to be at the first step in my rotation. So I to the 97th is I. Now, the only one we haven't seen an example of thus far is if I had a remainder of 2. And if I had a remainder of 2, then my second step would be negative 1. One final thing we're going to talk about, and that is rationalizing a denominator. Remember, I is the square root of negative 1. So if I have I in my denominator, that's like having a square root in the bottom, which we don't want. We've always rationalized denominators that way. So the way that we undo that is we multiply the top and the bottom by the reciprocal. So what the reciprocal is I take whatever operation is happening in my denominator and I switch the sign. So for this first example, I have 7 minus 6i in my denominator. So my reciprocal would be 7 plus 6i. So I'm going to multiply that in the top and the bottom. And we do have experience now multiplying these complex numbers. So I'm going to get 84i plus 72i squared in the top. And in the bottom, I'm going to get 49 plus 42i minus 42i minus 36i squared. So in the top, I've got 84i, and then remember, I squared is really negative 1. So this is going to be negative 72 plus 84i in my numerator. In my denominator, those middle terms are going to cancel, and I've got 49 minus 36i squared, which is really negative 1. Negative 36 times negative 1 is going to become positive, so I'm going to add 49 and 36 to get 85. And there I have my quotient now with no I in the denominator. Let's do this once more. Again, you just change the sign in the middle. So if my denominator is negative 9 plus 10i, my reciprocal is going to be negative 9 minus 10i. And that gets multiplied in the top and the bottom. So I'm going to be foiling in the top and the bottom this time. In my numerator, I'm going to get 27 plus 30i minus 72i minus 80i squared. And in the denominator, 81 plus 90i minus 90i minus 100i squared. So going through to simplify in my numerator, I've got 27. The i's subtract to negative 42i. And then I've got negative 80 times negative 1, which becomes positive 80, which I can add to the 27. And I'm running out of room, so 107 minus 42i is going to be my numerator. Then down in my denominator, I've got the 81. Those middle I terms will cancel, and then I have negative 100 times negative 1, which becomes plus, so I can add that to the 81. And I get 181. I don't have an I in the denominator anymore. And there is my final answer. And this wraps up our practice with complex numbers and operations.